Michael Roper, and this is episode number 511. So, welcome to the Smart Buildings Academy podcast. Today's episode will be about creating an effective alarm design and management strategy for large facilities. All the information covered in this episode can be found on our website at podcast.smartbuildingsacademy.com/511 for this particular podcast. All right, so now that we got the intro out of the way, let's go ahead and get into our main content. And before I start, I'd like to open up with a little question for you to think about. So if you're maybe a building engineer or maybe a BAS technician with a lot of customers at your office, and if you walked into your BAS alarm console right now, how many alarms would you see? And how many of those would actually matter, okay, that you really pay attention to, that have to be acknowledged as a critical alarm? Okay. In many facilities, some you might say, well, my alarm log set up perfectly and I don't have any issue with it. But most cases, the answer is going to be probably too many alarms. And most of them might not really matter. I don't even know why some of these alarms are here. Those are some old alarms. Maybe these are nuisance alarms and things like that. So really in this episode, we're going to talk about maybe how to fix that a little bit and maybe some strategies to improve the alarm design and maintenance on those alarms. So we're going to be talking about creating an alarm design and management strategy that cuts down on like nuisance alarms. It helps operators focus on their day-to-day operations without having to be interrupted with maybe some alarms that don't really matter, or if they do matter, what we have to do to follow up on those alarms to make them go away, hopefully permanently. And also, we're also going to hit on some ways to tie alarms into some real action items and some real follow-up items and things like that. So we're going to cover what alarms are and why they matter. We're going to define what an alarm is, the different types of alarms, and why they're very important in large facilities. Challenges large facilities face with alarms, we'll cover that too. And then we'll talk about how to design an alarm philosophy within your building system. All right. We'll go over some best practices for managing alarms in our day-to-day operations. And then we'll talk about some of the modern BAS tools and dashboards. We'll give some examples on those. A lot of different software, as we know, different user interfaces has different features. And we'll talk about a few of those today. And hopefully that can make our alarm management a little bit smarter and more efficient. And also, we're going to hit on our last item here, how alarms connect directly to energy efficiency and also maintenance strategies and keeping our tenants, their comfort levels to a high level and things like that. So by the end, you'll have a roadmap for tuning alarms and from chaos into more controlled, efficient strategies. Okay. So with that pretty long intro, we'll go ahead and dig into our first topic where we're going to talk about what are alarms in a building automation system. Okay, so let's define this real quick. So by definition, alarms are like signals that require operator action. Okay, so that's the whole reason for an alarm is we need to have some kind of action. All right, that's the critical distinction there. If no action is needed at all, it shouldn't even be set up as an alarm. It should be set up as some other things we can do in user management systems. Set them up as a notification. You can set them up as a trend, or you can even set them up as an event in your event log. Okay, so we need to make sure we make that distinction between what's an alarm and what's just a notification, or what's just a trend or an event. So some examples of an alarm would be like, maybe in your chill water plant, your chill water pump fails. That's going to send an alarm. That's a critical alarm. That has to be acknowledged. That's something that we definitely want to have some kind of action taken. Okay. If no action needs to be taken, if it's just a notification, then it doesn't need to be set up as an alarm. But in this case, that's pretty critical. And that's a piece of equipment. We want some action taken whenever the chill water pump fails. We got to have a technician go out there and investigate what happened there. Another example in an alarm, we can have it like if it exceeds a threshold of some kind. Okay, for example, if a temperature sensor in a room rises above 78 degrees for 10 minutes, If it goes over 10 minutes and it's still 78, we want an alarm. Okay, we're giving it 10 minutes to maybe come back down to set point. Okay, now that might be a very long deadband, but that's just an example. It could be any number on that. But regardless, if our temperature or any kind of threshold rises above a set point for a predetermined time frame, that's going to be an alarm. That means that our tenants are not going to be happy with the comfort within that space. Okay. Now, if we have a conference room that drifts like 1 degree from set point for 1 minute, this example, we might not want to put that in an alarm. Okay, that's not really an alarm. That's within the deadband, so we want to make sure we don't just keep going and tripping our alarms every other second. Okay, so we'll give it a little bit of time to catch up to set point. That's why we have deadbands, obviously. Okay, so too often we see systems using alarms for every single thing. Okay, anytime maybe the chill water system starts, there's an alarm. That should just be a notification. Okay, whenever someone logs in, maybe that's not really an alarm. Maybe that's just a notification. So the result, if you have too many alarms, operators stop trusting alarms. We all know this, and we're just like this. They just become a nuisance. It's another job. It's another job duty that we have to do, is just checking out all these alarms, and they're just overwhelming the system with too many to read, and we don't have time to do that. So that's kind of what happens if we just try to make an alarm for every single thing. Now let's go over some challenges with alarms in large facilities. Okay, so big facilities face alarm overload because we have a lot of equipment, obviously. All right. So we're going to talk about some common problems in this section here. And the first one we're going to start with, and we kind of talked about this already, is alarm flooding. Okay. So for example, one fan trip creates 30 downstream zone alarms. Okay. So maybe you have an air handler and it's supplying, it's a VAV air handler with maybe 30 VAV boxes in 30 zones. Well, if that fan trips, then you're probably going to get a high discharge temperature on every single one of those. Okay. Or maybe a low discharge temp. All right. And that's going to trigger an alarm. So some modern building automation systems, which we'll talk about, has some features called alarm suppression, where you can suppress alarms like that fan if it trips. You can make a rule in there to where if that fan trips, then let's not go ahead and trigger an alarm for the discharge air temp, high temperature alarm, for example, because that's going to affect the cold air that's going to that VAV box. Okay, it could exceed a discharge air temp set point or something. All right, so that's things that go downstream alarms. So anything that's upstream will affect a downstream zone alarm. So that's a really important one too, alarm flooding. So just keep in mind on that. And if your user interface has that feature, some of them do. I've worked with a few different vendors, and they do have alarm suppression. So look into that and see if yours has that. If not, let us know in the comments, and maybe somebody else knows the answer to that with your vendor, if they do it or not. Another one's the nuisance alarm. So this is whenever the thresholds are too tight. Okay, we talked about deadbands a little bit in the previous example. So if the thresholds are too tight, you don't have enough of a deadband. If you're saying we want it to go to cool mode, cool mode, if it goes, half a degree over set point, or if it just goes 1 degree over set point, that's going to be too tight of a threshold, you would think. You need to give it a little bit of a deadband just to make sure it has time to catch back up to set point. Just give it a chance. That way it's not swinging back and forth, going between different modes and things like that. You'll get false positives everywhere with these alarms because it went back to set point, and it just gets kind of messy with the nuisance alarms. Okay. And we'll also talk about some strategies on, eliminating some nuisance alarms as we go through this as well. Poor prioritization. Okay. So what's a priority and what's not? So this would be a good example that leads into nuisance alarms, really. So like a dirty filter looks the same as a chiller trip. So a dirty filter, it's not good. Okay. We definitely got to have some action. If we get a clogged filter, it's going to affect the airflow. But that might just be not maybe a warning or a notification. A chiller trip That's going to bring down the whole chill water system, and we're not going to get any kind of cooling to our zones, okay, with the chiller trip. So that's a critical issue. The air handler can probably still operate with a dirty filter as long as it's not too clogged up and we have some minimum flow by design. But if it gets too dirty, of course, that's whenever it's going to cause some issues on that. Okay. Multiple BAS platforms. Okay. So this is a challenge we have with different alarm logs and configurations. You might have, different vendors in your building automation system. You might have a Niagara system, a Honeywell system. You might have a Siemens system. You might have a Train system or a JCI. All different systems. You might have 4 different building automation systems, but they all alarm differently. They have different rules for alarming. All right. So trying to get those on the same page and make them a uniform way to do that, a standard way to make alarming, would make things a lot easier. But that is a challenge that a lot of us have in modern building automation systems, because as time goes on, maybe another vendor got into your building and now you have more than one vendors in your building. Okay. Operator gaps is another challenge we see in large facilities, because most of the time when we get to larger facilities, sometimes the software is going to be more sophisticated. So alarms without clear response actions could also be an issue as well. So it's not only operating the software and being able to acknowledge the alarm, or determining what's going to be a critical alarm, what's going to be just a warning. So we need to have a clear response whenever a certain alarm happens. Okay, for example, if a dirty filter alarm happens, what is going to be our response to that? If a chiller trips, if a chiller goes down, we have an alarm. What's going to be our response to that? So every alarm that really you identify in your building, there needs to be some kind of response action or a follow-up to that, and that needs to be discussed within your facility management team. Okay. So we do have some standards that apply to this. Actually, it's the ISA 18.2. So these were developed in the industry, and they sent out an alarm life cycle that applies just as well to BAS and things like that. Okay, we won't get into too much on the standard thing there, because we're going to get into designing an alarm strategy next, which is pretty important. All right, so let's talk about an alarm philosophy. Okay, let's design an alarm strategy. We're going to go through 5 steps here on how to do that. I'm going to walk you through that. So the first step we need to do is we need to write down our thoughts, write down the philosophy on a document, and define what counts as an alarm in your building, okay, and how they're going to be prioritized and how they're named, okay? So come up with some standards, write them down, document them, okay? You can put them on an electronic file, Word document, an Excel spreadsheet. When you need to define these, it take a little time to do this. It'll save a ton of time and organization down the road. Okay, so we have some categories, and these might line up with your user interface. The first one's going to be a critical type alarm, okay? This is whenever it poses a safety risk and also an equipment risk, okay? This can damage equipment, or it might be a life safety issue, maybe like a smoke detector, like a smoke shutdown or something like that. If the smoke detector trips, that's going to be definitely a critical alarm, because that's a life safety issue. Okay, so we want to make sure we identify only critical alarms that pose these safety issues or equipment risk too as well, to damage it even further. Okay, the next one we have is a major, could be like a major type alarm. And these can be named other things depending on your building automation system and how you want to define these. And a lot of these building automation systems, you can set up custom alarms like this too, if you have administration rights to do that. A major alarm is like a comfort or production critical, okay? So maybe it's a major alarm, it's in a conference room, all right? This is where our tenants are at, and we want to make sure that their comfort levels are satisfied, or they're going to go home, or they're not going to show up to work, or they're going to complain, or their production is going to decrease, okay? So a lot of our customers, I'm saying that from a building automation, technician point of view, and also maybe from the building engineer point of view, they're your customers too. the people in your building, we want to make sure they stay comfortable. Okay, that's one of the main reasons why we're here, is to make sure that happens. Or production critical. Okay, so this can happen if you're working with a company, maybe it's a process. All right, so maybe it's a manufacturing facility that has to have a certain temperature set point, or it could be like a medical facility in a surgery room. Okay, that's production critical. Okay, it's also a life safety if you want to consider it that as well. So that could be deemed, if it's in a health environment, critical alarm, but definitely a major alarm. Okay, and the next one we have here, the third one down, that's not as important as the first two, the critical and the major alarm, is a minor alarm. So these are non-urgent, but they're important. It could be like the dirty filter switch. Okay, it's not urgent, but it is important. We got to put that on our list. It doesn't have to be addressed right away. If we're going to, make our, most important task to knock out first, that would not be the first one. Okay, if you have some other things you got to do, maybe you have an air handler down or a chiller plant down, those are definitely going to come before the minor alarm. Okay. So that's the third level. And then the fourth level, which would probably not be as important, but it is good to know, it's called like an advisory alarm or a notification alarm. This is for informational use only. Okay. Maybe it's like the chill water plant started today, or the air handler started, and we want to make sure it started. It's important that we know it started, but we don't really care that much. It's just informational. It's like, okay, good. It's a good for peace of mind. You might have to react to it if, for example, the chill water plant didn't come on, you're expecting it to come on. Okay, so it's just informational use only. It's like an advisory or notification. Okay, step 2, we got to rationalize our alarms. Okay, we talked about this a little bit in the beginning. For every alarm point, ask yourself, does it require action? Okay, when does it require action? Okay, how soon do we need to produce some action to that item? All right, so the dirty filter, we might be able to put that off till next week or next month, depending on what your protocol is there. If you're on a regular filter change, you could do that, or you can just replace it right away, depending on if it keeps tripping on that. Okay, so that, but a chiller plant does require action. What kind of action? When it does? Who's going to address that action too as well? What happens if it's ignored? This is question number 2. What if we ignored that alarm? What if we ignored that the chill water pump failed and we just ignored it and hoped that it just came back on again or overrode it back on? Okay, what happens to the system? All right. What happens if we have a sensor failure? Things like that. Could automation handle it instead? Okay, so if there's ever like any kind of condition that went down, is there like some kind of program that can jump in? A lot of times you could trigger a program to initiate based on an alarm. Okay, so just things like that. It could be a custom program that you made and things like that. Okay, so rationalize the alarm. Yeah, and this really determines what kind of alarm do we need to set it up as, and how important is it, and who's going to address it, and when the alarm happens. Okay, so that's step 2, alarm rationalization. Third is our thresholds and deadbands. Okay, so this is really important too, and this can eliminate nuisance alarms. Okay, alarms that just pop in all the time. So set realistic thresholds. Don't make them like too far of a deadband, or too much of a deadband, or too tight of a deadband. Too tight, you're gonna get nuisance. Too large of a deadband, you might not ever get any alarms, and your tenants are suffering with poor comfort levels in their building. Okay, or you'll get complaints. Add time delays. Okay, that's really important too. Between anytime you're cycling between modes, pumps, add some time delays there. This prevents alarms from chattering or nuisance alarms. So just make sure you're aware of that with your thresholds there. Step 4, suppression and masking. We talked about this a little bit ahead or in the introduction. Suppress alarms when equipment is off. All right. This prevents nuisance cascades. For example, if you turned your air handler off but maybe your zone for some reason was picking up the alarm downstream and it's saying, hey, we're not getting cold air from your VAV air handler. We can suppress that alarm on that discharge air temperature on the VAV box, like we said before, anytime the fan is off. Okay, so anytime equipment's off, maybe the chill water system's off too, and you have a hot zone. Well, that's not the zone's fault, the VAV box's fault. That's the fault of the chill water plant. That's going to be the alarm over there. So it doesn't matter about the VAV alarm. That's a useless notification, really, because the real problem is going to be in the chill water plant. And that's where it has to be addressed. And also grouping and hierarchy, report root causes first. Okay, so it's going to be the most critical items first. Don't bury operators in downstream symptoms like we just talked about. Okay. Next, let's talk about alarms in operation. So the design, like we talked about, gets you started, but ongoing management is what makes it work. Okay, keeping up with it. So you might start out, but we got to make sure we maintain that as time goes on. So the first point we're going to talk about is prioritization and escalation. So critical alarms must stand out and escalate if they're ignored. So a lot of times we're going to make those a critical alarm in the user configuration or the alarm configuration, and they're going to have an acknowledgement. Okay, someone has to physically go acknowledge in the user interface software where you connect to the building automation system with, in order to acknowledge, who acknowledged the alarm, when they did it, and what timestamp it was. Okay. Response plans. This is another good way to do this. Each alarm should have a clear operator action. So anytime we get like a chill water pump failure, everybody on your team should know what needs to happen, what protocol is going to happen when that alarm happens. Who's going to be the lead on that? Okay, who's going to assist? Okay, what support are we going to need? Are we going to have to sub this out to a contractor to fix? Okay, or can we do this in-house? So there's a lot of questions you should ask. What ifs? What if this alarm happens? What do we do next? Okay, not ignore the alarm for sure. All right, training and simulation, run alarms response drills regularly. So maybe even just run just practice like a critical alarm shutdown. Maybe an air handler shutdown. You didn't know it wasn't supposed to, unplanned. That's what I was trying to say, an unplanned shutdown. So you can practice those drills, see what will happen, get your team involved, get everybody on there and make sure everybody, it's kind of like a fire drill for equipment, I guess you could say. All right. Audits, it's good to do quarterly reviews. Just check your alarm log. Maybe you removed a piece of equipment, or you decided that an alarm's not important anymore, or maybe somebody added one that shouldn't be there. And this is a chance to audit your system, remove any old alarms that are in there that are not needed anymore. Okay. Or maybe there's some nuisance alarms too, or maybe some alarm suppression that we have to add in there too as well. Okay. If you have any kind of maintenance software, that integration is important too. A lot of you, the building engineers and building operators, you might have a custom maintenance software in your building. So those alarms can generate maintenance work orders automatically, potentially. So just think about that, how those alarms can interface with your current software if they're able to. They might not be able to, but if they are, look into that, because they can generate maintenance work orders automatically for your team and just make it more easy on the organization part of it. Okay, so let's talk about some best practices for alarming. So modern building automation system platforms provide a lot of tools that can make your alarms more effective and easy to use and more efficient. So a lot of these, you've probably seen these on the market. A lot of different vendors have different ways to do alarms. Okay, so any of them you look at, they provide a unified view, a very simple Windows-based view, and operators can filter alarms, and they can prioritize those by the severity. You can organize the columns for what's all the critical alarms, all the notification alarms, and things like that, and just be able to acknowledge those from the user interface. Okay. Also, we have mobile notifications and filtering. So that's another powerful tool that we have today. We can push alarms to our field techs via apps, through their smartphone, email, things like that. You can also filter alarms, just so critical ones will, notify somebody when they need to address something. So, for example, you don't want your technician that's on call all weekend to be getting notification alarms at 2 o'clock in the morning. That wouldn't be good. So, just make sure we filter those and set those up. If you're going to be doing mobile notifications with your team, only make the critical ones. Notify your technicians, especially if it's after hours. That can help out too with them. Alarm KPIs, which is the key performance indicators and reporting. So a lot of companies are doing this to kind of stay on top of their building and see how they can improve it. So these key performance indicators might show top recurring alarms that keep coming up. All right, this might be something you need to evaluate to see what was the cause of that alarm. Why does that keep surfacing? Long-standing alarms, ones that just stay in the alarm log for a long time. And acknowledge times, how long it takes to acknowledge an alarm, because in the user interface, it tracks when that alarm came in and when it was acknowledged. Okay. So key performance indicators like that, those are maybe some that could apply to alarms. They just help your facility focus on the problems of the equipment and digging deeper to find the solution on what happened there. Also, we have standardization across different platforms. So make chiller trip mean the same thing no matter what the BAS vendor. So make sure your naming is consistent, even if you have different building automation systems in your building. Okay. Make sure these names are the same. Don't make chiller trip in one system. If you have one vendor over here and the other one's called chiller failure or something like that. Okay. Make them all uniform, make them the same. That's a good tip, just to make them standardized across your different platforms if you have that in your building. Avoid operator confusion, especially on multi-campus sites. All right, so the things like that, just standardization helps that. If you're working on a big like university with multiple buildings or something like that, military base, a hospital that has multiple campus, multiple buildings on it, that just helps cut down the confusion on naming. Okay. Okay, so let's go ahead and talk about one of our last topics here. Alarms, energy efficiency, and maintenance. So alarms can really tie directly to these items here: energy efficiency and maintenance. Those are two big things here. So they tie directly to these. For energy efficiency, poorly tuned alarms hide efficiency issues, okay? Like short cycling chillers, okay? So if if you're not catching those short cycling of the chillers, every time that ramps up, that's going to cause an inrush of current, and that's going to cost you a lot of kilowatts. That inrush current, then when you first start those chillers, compressors, anything you're talking about, could be a packaged rooftop unit too as well. So that can affect your energy efficiency and energy use in your building. An economizer that might be stuck closed, all right? That could also have an issue too on it too. If we're not getting an alarm, if our actuator failed, okay, if we're not getting airflow, our free cooling is gone at that point. Also can affect your indoor air quality too as well. So good alarms will reveal the waste and some things that will help us save energy. Like it could be even like a zone that's in reheat. It's stuck in reheat and it won't go out of reheat. Or equipment that's not running with the right schedule. Okay, maybe we have equipment that's running all the time and we're not scheduling it. Okay. Now, predictive maintenance also plays a role with alarms. So alarms can provide early warning for things like differential pressure rising across filters. I know I use that example a lot, but that's another thing that can cause, an early warning issue. Pump vibrations increasing. Okay, that might be why our pump keeps shutting down. Okay, keeps failing. Or you may have a mechanical room temperature trending upward, things like that, and it could cause some issues. Last, we also have operational liability. This is when alarms are tuned and prioritized. Operators trust them. Okay, so we know these are useful alarms. We're buying into it more. Okay, we know when an alarm comes in, it's important. We got to go address it. And then we know how to address it too, because we've already talked about it as a team. Who's going to do it? When are they going to do it? And how are they going to do it? Okay, and it just makes your team more confident in the system. They respond faster, and it also, most importantly, avoids downtime with our tenants in the building. It gives them increased comfort control. Okay. All right. Well, that's pretty much all I'm going to talk about really in this podcast. Just some key takeaways. We'll kind of wrap up here real quick. So, whenever you're doing these strategies here, start with an alarm philosophy like we talked about. Okay. What do we want our alarms to look like? Okay. What's going to be a critical alarm? What's going to be a major alarm, a minor alarm, or just a notification? Okay. We need to define those, rationalize our alarms. If no action is needed, remove it, get rid of it. We don't want any nuisance alarms in there because it just creates more work and it's messy, and we want to get rid of those. Number 3, another point here, use thresholds. Okay, remember we talked about thresholds or dead bands. Make sure that we have a little bit of a dead band, like on a temperature set point. Make it a 2 to 3 degree dead band. That way it's not going into alarm when it just goes over, point or half a degree or 1 degree. Give it a little bit of time to catch back up to set point. Okay. That'll help out a lot. Also, alarm suppression. We talked about that. If there's anything that's downstream that might go into alarm by something that's affecting it upstream, such as like your supply fan, that can cause some issues on that. Actually, I think I got those reversed. Downstream would have been the VAV box. Upstream would have been the fan. Anyways, the details on that. So that would help eliminate nuisance alarm as that alarm suppression by eliminating, alarms upstream that can cause issues downstream. Also, manage alarms continuously with audits. So check in with your system, look at your alarm log, maybe go as a team and decide together. Is this really necessary? Is conference room 102 really still an issue? If it's not an issue anymore, get rid of it. Okay. Or you can reclassify it. If it's a critical alarm, it's waking people up at 2 a.m, whoever's on call. Can we just change this to like a notification alarm and we can address it the next day or something? Also, training, make sure your team understands how to use the alarm log, knows when to acknowledge it, who to contact if there's any issues. So that just kind of ties into escalation paths for that. And then last, we talked about energy efficiency and maintenance strategies. So tie alarms into that. Make sure we're definitely monitoring parts of our equipment that contribute to energy efficiency, like economizers, okay, chillers and things like that. If it's short cycling, okay, humidity sensors, if you're monitoring humidity in spaces, enthalpy controls. Okay, so the goal is fewer alarms, but better alarms, okay, more quality alarms that are meaningful to the system. Okay. All right, well, that's all I got on the podcast today. I'm going to go ahead and wrap up with the ending. So I just want to thank you for listening to the Smart Buildings Academy podcast. We hope you learned a lot from this episode. And if you found this episode valuable, please leave us a 5-star review on Apple Podcast or Spotify. If you're watching on YouTube, please like, comment, and subscribe. And as always, this episode will be available on our website at podcast.smartbuildingsacademy.com/511. All right. Well, thank you very much. And we'll see you all next week on the next week's podcast.